A certain computer algorithm executes twice as many operations when it is run with an input of size k as when it is run with an input of size k minus 1, where k is an integer that is greater than 1. When the algorithm is run with an input of size 1, it executes 7 operations. How many operations does it execute when it is run with an input of size 25? So I'll make a little table here where on the left column we'll have the input size and on the right column we have the number of operations. So we're told when the input size is 1, then the algorithm executes 7 operations. But we're also told that if we increment the input size by 1, then the number of operations doubles. And so for an input size of 2, this would be 14 operations. And then for an input size of 3, this would be 28 operations, and so on. Each time we increment the input size by 1, we're multiplying the number of operations by 2. And so there's this common factor here that we're multiplying by each time we increment the input size by 1, which means that this is a geometric sequence. And geometric sequences are great because you can just write a sub n as the first term, which in this case is 7, and then times 2 to the power of, in this case, when n equals 1, we don't want to multiply any powers of 2. So I'll write n minus 1 in the exponent so that when n equals 1, the first exponent is 0. But then after that, the exponent increments by 1 each time. From here, we can quickly evaluate a sub 25. A sub 25 would be 7 times 2 to the 24th power. And that's a pretty big number. And that's a number that you probably wouldn't be able to find using a calculator. Thanks, everyone, and I'll see you in the next video.